as you can see, we're taking a look at problems with 3 different equations and 3 different variables. We need to make sure that we set these up correctly and follow the process so they'll be easier for us to solve. Now, if you remember from class, when we go over these, the equations may not always look like this, and you may not get exact answers. If you get something when you're working with the problem so that all of your variables go away and you end up with some number equals the same number, like 5 equals 5 or something weird like that. If they're the same, then the answer is many solutions. If you end up with 2 different answers, like 4 equals 5, there's no solution to the equation or to the 3 equations. So keep that in mind when you're working these. So make sure you've looked at the problems in the book, make sure you've taken notes in class so that you know how to handle problems that may be a little different than this one. We're going to look at this one right now though, and it does have 3 equations and 3 variables. So what I've told you in class is to make sure that you label your equations as 1, 2, 3. So we'll label these as the top one will be 1, the second one will be 2, and the third one will be 3. So maybe we should go ahead and do that so we don't get confused. We talked about one of the reasons we wanted to label these is so that we could be precise when we did the problems. And I've grouped 1 with 2 and 1 with 3 as 2 separate problems, and we work on solving these as 2 separate problems. So that's what we'll do next. I'm going to work on the first set first, the one on the left. And what we want to do is we want to do substitution or elimination and get rid of one set of the variables. And we want to do that for both the left set of equations and for the right set of equations. And I'm looking at the one on the left and thinking that since the y's are already set up so that they eliminate, they're already set up for that, I'm going to go ahead and do that, which means that I need to eliminate the y's on the right hand side too. Now you get to choose which one you want to eliminate, so just make sure that you're choosing the same one for both of them. So I'm going to eliminate the y's in both of them. Now here's an interesting thing that's happened here. The z's were also set up for elimination. Now that's not always going to happen. Sometimes just one of the variables will eliminate. This is a good thing in this problem because that means that we already know what our x value is. If we didn't know that, we would still need to pair up this equation with the other new one that we're about to form. So in this equation, x is going to be equal to 1. Now we want to go over here to the right-hand side. Since I had chosen the y variable, I want to make sure I eliminate the y's on this one. And I could have done the z's for that matter. Either one would have been okay, but I purposely made up my mind when I started that I was going to eliminate the y's. So I see that we have a plus and a minus. The way to eliminate it would be to make a 2 here, and I already have a 2 here. So I would want to multiply this row by 2. So I would end up with 2x up there, and 2y, and 2z, and 12. This just substitutes for this top equation. I've just made a brand new equation now. Now I want to add this one and this one. Those are my 2 new equations that I want to take care of. So I'm just going to add them. And here I get a 5x. This one eliminates, which is what I wanted. Here I get a 3z. And here I get 0 plus 12 is 12. Now the next step is very important. What you want to do is you want to take your new equation from the left and your new equation from the right, stack them on top of each other, and do substitution or elimination for that set of equations. It's like a whole new problem. So I'm going to take my left equation, and it could have 2 variables in it, but they're going to be the same variables. So if the one on the right has x and z in it, the one on the left is going to have x and z in it, or just the x in this case. You won't have 3 different variables anymore if you've done this correctly. So let's stack those equations. Now you want to look at your problem, your new problem, and see if it would be better to do substitution or elimination. This one would be by far easier to do substitution because I already know what x is. I can substitute that x into the other equation and have a new answer out of this one. If I had two variables in both of them, I would probably want to stack them and do elimination. But you just need to decide that as you get to this step. So I'm going to do substitution. Now notice all I've done is substituted the 1 in for the x. And you just simply do your math now. 5 plus 3z is going to equal 12. And then do your algebra. Now here we're getting an answer of z equals 7/3. So right now I know that x is 1, z is 7/3. I still don't have the y value. So I need to go back up to somewhere in the problem, preferably at the very beginning, and find an equation that has x, z, and y in it, and substitute in the two that I know, and try to find one that I don't know. So I'm going to go back up here at the top and take a look. Looks like I have, for the very first equation, x plus y plus z equals 6. So let's just use that one. X plus y plus z equals 6. And it looks like, if I've done my math correctly, that y is going to be 8/3. Now, what you really want to do is take these answers, and we have 3 of them now. We have an ordered triple of 1 8/3, because that's the y value, and 7/3. And we want to go up and we want to check it. We don't want to check it in the one that we just used, because that's the one that these all came from. We want to check it in one of the other ones, at least one of the other ones, maybe preferably both of them. So we have 2x minus y minus z equals minus 3. So we want to go and we want to see if that's going to work. All I've done here is I've taken 2x minus y minus z equals minus 3, and I've substituted my x, my y, and my z into the equation. I've done the math. I get down to the bottom and I have -9/3 equals -3. And we know that to be true. Just to be on the safe side, I would probably take the third equation and check it too. I've played it safe and I've taken the last equation, 3x minus 2y plus z equals 0. I've substituted my 3 values in that equation and I've checked the math. So I know that my solutions, 1, 8/3, and 7/3, actually work for all 3 equations. That's the best way to play it if you want to make sure that you're completely right. Make sure that they work for all 3 equations that you have.